coming in the same order that they're in their lab manual. And we'll begin by looking at the external features of the sheep brain. Here at the upper surface here, this convoluted, highly folded portion is called the cerebrum. Just behind the cerebrum, this other large structure here, is the cerebellum. The two portions of the cerebrum are divided by a groove here. This deep groove is called the great longitudinal fissure. It's between the two hemispheres of the cerebrum. We have another fissure which divides the cerebrum from the cerebellum. So just this indentation here, this division line, this would be the transverse fissure. The cerebrum is divided up into lobes the same way that you divide up the bones of the skull, and they're named in the same fashion. So we have a frontal lobe here on each side, parietal lobe, sides of the cerebrum. The temporal lobe is kind of stuck a little bit down underneath here. And the occipital lobe, which is the back portion of the cerebrum back here beneath the occipital bone. There's also a central fissure, which is a little difficult to see on a sheep's brain. It's a structure which is pretty remarkable on a human brain, but on a sheep's brain it's kind of indefinite. But basically it's a dividing line between the frontal lobe and the parietal lobe. I think on this brain, our central fissure would be right along in this group, not as deep as the other fissures. In addition, from the outside, we can see the pons and the medulla. I'm going to flip the brain over here so that we can see those structures on the lower portion here. Looking at an inferior view of the sheep's brain right now. The pons actually at this moment is partially covered by this.
That membrane again to a lot of you guys, it's usually you see guys anchored to the bottom.
Would be the region of the
We
pons.
took it off. That's the pons right here.
And just behind it, this other enlargement area right here until it turns into the spinal cord and continues on out. This region would be the medulla oblongata. Okay, having located those external structures, we're now going to look at the internal structures. We're going to take a sagittal section, so you're going to cut your sheep's brain
Yours have been cut. Let's
right
try
down
to keep
through
the
the
two
great
halves together. Do
longitudinal
not
fissure. You can
separate the
continue
two
your
halves.
incision right through the cerebellum and down through the spinal cord so that we fold the brain open into two halves. When you make this cut, you want to do it with a minimum amount of back and forth sawing that you can possibly do. Try to make the cut just a nice, sharp, smooth cut, one single cut if you possibly can. I've got a brain here that we have already open, and we'll take a look at the insides of this. So we're looking at an inferior view right now. I'll turn it back over to the superior view. It'll fall in half like this when you've made your cut. Okay, looking at the halves here, we can see that on the inside of the cerebellum, here's the cerebellum in the sagittal section, we can see that there's two kinds of material in the cerebellum. There's this darker outer gray matter, and then there's a branched pattern of white matter. The branching pattern of the white matter is called the arbor vitae. It means tree of life. It's a branching tree-like pattern. If we look more up into the regions of the cerebrum here, I'm actually going to switch halves on us here. This one might show better what I want to look at here. There are cavities in the cerebrum, in the brain. One of the cavities would be right here in this half. As I open up this opening, this is called the lateral ventricle. There are two lateral ventricles, so there's one in this hemisphere of the cerebrum. There's also one in the other hemisphere. The third ventricle then would be a region below this, which if I pull this apart a little bit in here, we can see some of this, this brownish material is actually within that other ventricle. So there's another cavity or another space right there where the probe is running. We've actually sectioned through the third ventricle, right through the center of it. So we have a half of it in this hemisphere and the other half of it's over there. So it actually comes down and actually surrounds this entire region. This large structure here passes right through the center of that third ventricle. So if we keep following on down this direction, we'll come to the fourth ventricle. And the fourth ventricle is along this little channel right here. And as it turns into the cerebellum rather here, there's a little opening. And that other opening right in there, that extra little channel into there, would be the fourth ventricle. Okay, going back up here, we'll look at the corpus callosum. I think I'm going to switch us back again. Look at this one, a little better here. Here's the corpus callosum. It's a band of white matter. It's a white matter fiber tract that connects between the two hemispheres. So we can see it on both halves, it just happens to be a little more defined on this particular half. That's the corpus callosum. Extending off from the back end of the corpus callosum and coming forward, the little tongue sort of, I'm gonna open
So
up
she
the
should have stopped with the other one.
She's
Bullshitting you, basically, right?
the lateral ventricle a little there.
This is the lateral ventricle, that little opening right there. The white band on top is the corpus callosum. And that little tiny one on the bottom here, okay, well, that one's the fornix. Okay? So she's struggling with this one, she should have kept it with the other one, all right?
You can see the fornix coming down.
There,
See,
see?
this shows it quite well, actually. Here's the corpus callosum. And then this white projection coming down here would be the fornix. And the lateral ventricle would be up inside there. We have an aqueduct of Sylvius,
So
which
this next
connects
one
from
is
the
not
third
in your
ventricle, this area down here, down to the fourth ventricle. It runs from out of the third ventricle, behind this large lump right here, we'll name that in just a minute, comes straight down through here, and this passageway up
So
into
the
the
next thing
fourth
we're gonna look at is
ventricle.
the
The entire
mammillary body.
passageway is called
Right.
the aqueduct of Sylvius, or the cerebral aqueduct, that channel through there. Connects the third and fourth ventricle.
Mammillary body.
Mammillary body is a structure which we can see from the outside as well. I'll go back and show you that on the outside view, but we can see it internally here as a structure that's been sectioned in half right there. When we review through the cranial nerves on the outside, I'll show you again where it is on the outside. We can compare that location to this inside
This one is
location for
the
the
pineal body,
body.
that's the pineal body right there.
The pineal body is quite a bit larger in a sheep than it is in a human relative to the proportional size of the brain. It's this other round structure right here. This is one half of it. We sliced through it by making a sagittal section. Corpora quadrigemina actually means four bodies.
Okay, so
There
this next
are
one,
four structures that make up the
Let's,
corpora
put the two halves
quadrigemina.
together.
There are two superior colliculi and two inferior
and then what you're
colliculi.
gonna do is, with one hand, you're gonna grab the cerebrum, which is the large part, and the other hand, you're gonna grab the cerebellum, which is the smaller part, and then very gently flex the two like this. Okay, so you kind of expose what's inside that transverse figure. Okay, so when you do that, do you see basically it looks like two butts mooning you, right? So you have a bigger butt on top with two big butt cheeks, and then you have a smaller butt on the bottom with two smaller butt cheeks. Okay, so all four butt cheeks in total, well, we call that the corpora quadrigemina, right? But the two bigger butt cheeks on top, we call those the two superior colliculi, and the two smaller butt cheeks on the bottom, we call those the inferior colliculi. Okay, but as a whole, corpora quadrigemina.
One half of the corpora quadrigemina. The total corpora quadrigemina requires two superior colliculi, one from each side, so we need the whole brain together. Actually, I think what I'll do is I'll take this other one that is still intact, fold it open, and let you see the whole corpora quadrigemina. Two superior colliculi, two inferior colliculi, making up the corpora quadrigemina.
Superior, inferior, corpora quadrigemina.
Okay, back to our sagittal section here. See which brain has got the structures I want to
Okay,
look
so the
at.
next thing we're gonna look at is something called a thalamus. And you can see that thalamus is that ball right there.
Straight back from that up into this region, there's a posterior commissure right
This
in
one
here.
right here can be our
Another little small dot of white
Okay,
tissue.
so I have my mammillary body here, my pineal body here.
Between the anterior commissure and the posterior commissure is this very large mass. This is called the thalamus, or this is a portion of the thalamus. Actually, the thalamus continues back down into the hemisphere there, but this enlarged portion right here would be the thalamus.
The next one is the hypothalamus.
Hypothalamus, hypo means below, so we would look for the hypothalamus below the thalamus. It's this region right in here, between this enlargement here and this mammillary body.
That's the optic nerve, that's actually the optic chiasma.
This
right
other
there.
area, kind of
There's your
grayish
mammillary body,
here,
between the
would
optic
be the
nerve and the
hypothalamus.
mammillary body, well, you have the hypothalamus.
The pituitary gland is not on
Okay,
this
so
particular
5
brain.
of the 6
It's been
groups
removed
has
so
that little
we can
membrane
insert
at
that section easily.
And I
If your
pointed out,
pituitary gland is still
pituitary
in
gland.
place, it'll be a
And
large
so,
structure, it'll be right about here, hanging off
typically,
the under
they're
surface.
not
I
separate.
do have a pituitary gland still in
You
place
find
on
the
this one.
pituitary gland on the underside of the brain.
With the
okay?
membrane still intact,
here
but
she
now
has-
on the inferior view, this large structure right here is the
So
pituitary
this is the
gland.
underside of
In
the
order to
brain.
see the cranial
There's that
nerve, it's
membrane
going to be our
idea.
next step, we're going to have to
Okay.
remove this entire piece of membrane along
And
with
then
the
the pituitary
pituitary
gland is
gland.
right there.
so that we can get down and look at those
Okay.
cranial nerves. If you haven't done that already, then you'll need to do that, but you'll need to be very careful in the way that you remove this membrane.
Now, what you're gonna
These
notice,
are
guys,
the
like you
small
say
white
right now,
fibers you can possibly see on
is
this
that these
brain.
fibers
For
here
example, right here,
and here,
right here,
there's the stuff
are
that
two
holds
small
that
cranial nerves.
membrane
This happens to
together.
be cranial nerve pair number 6.
So, with these ones, we didn't
And
take
you
them
can see
off,
that this is anchored
we
to
got them
this
like
membrane.
this, and whoever took them off, they
There'll
just
be
had
actually
to
several
yank
pairs
that
of
membrane
nerves that
off.
are
What's gonna
anchored to
happen
the
to these
membrane. You
cranial
have to
nerves?
locate
You
those
just yank
first
it off.
and be very careful to
You're
clip
gonna
them
break
away
them
from
off,
the membrane
okay?
before you remove this.
So we're gonna see, we don't have very long
They're
ones like
small,
you see
they're
here.
fragile.
They're gonna be pretty short because of the way that membrane was.
Okay, the next thing we're gonna do is I'm gonna move to a model, a human brain model, to show you the cranial nerves.
Okay, so she has a model. The model, what we're gonna talk about now are the 6 cranial nerves. Okay, I think it's on page 18. And the brain she's using is from a student that dissected that membrane off so well that the cranial nerves have been left intact and they're very, very long, all right? So, because of the way we got these brains, okay, you're not looking for these long, luxurious cranial nerves now. You're looking for